Hi everyone, and welcome back to the lab. In this video, I'll be making a compound called sulfur monochloride, which has an empirical formula of SCl, but is represented mostly by its dimer S2Cl2, if you try and take, say, the molecular weight of that. It's very easily made, actually. It's just the fusion of the elements. You have sulfur and chlorine, which gives you a mixture of sulfur chlorides. 3 sulfur chlorides, to my knowledge, exist. We have S2Cl2, SCl2, and then there's an unstable SCl4 that exists just below its melting point, I think of minus 30 C or so. So we'll not see that. But what's going to happen here is we'll set up a standard chlorine generator and essentially pass some chlorine over molten sulfur. And the molten sulfur will absorb the chlorine, forming S2Cl2 as well as some SCl2, since we don't really know exactly how much chlorine is going to be in the mix. Anyway, the sulfur, the hot sulfur, will be in a flask, which is set up with a distillation type setup. So as soon as the S2Cl2 is formed, or any sulfur chlorides for that matter, they'll distill off and end up in a flask. And then what we can do is take this mixture of sulfur chlorides, this being a straw-colored liquid and this being a blood-red liquid, and we can tell about the proportion by looking at the color of that. We'll just add a bunch of excess sulfur to that mixture, which will ensure complete conversion to what we want, which is S2Cl2, and then distill that again from the flask with the excess sulfur, giving us some fairly pure S2Cl2. Once you have a known pure sample of S2Cl2, it's pretty easy to go to pure SCl2 from that, because you can just simply bubble chlorine into this until you have a weight gain that corresponds to the SCl2 empirical formula. I've set up the apparatus, and I'll do a quick rundown of that. We've got a 1 liter round bottom flask to contain the calcium hypochlorite. This is essentially a giant chlorine generator. 1 liter, and then a 500 milliliter pressure equalizing addition funnel with a drying tube on here. This will be filled with calcium chloride. The chloride will be led through this tube, down this glass tube, into the bottom of this 500 milliliter flask, which will contain the sulfur. And this will deliver the chlorine to the sulfur, and the heating mantle will keep the sulfur hot. Any sulfur chlorides that form then will distill off through the still head. I'm going to replace these with metal clips because these will probably melt. This whole thing is going to be at about 200 Celsius. And then they'll condense. The sulfur chlorides, that is, will condense in this condenser here and collect in this flask for further processing. So let's charge the reagents. That's 96 grams of sulfur. (225 grams of 68% calcium hypochlorite. It's just a cool shock. We'll pack the drying tube now. Anhydrous, or I guess this is calcium chloride monohydrate. Need to get some better funnels. There we go. I'd normally be using towels and stuff for this and lab rags and stuff, but none of these things are particularly dangerous. Cotton, like that, and the stopper. Make sure that fits nice and tightly. It'll be under pressure. Leave that temporarily because we still need to get the HCl in there. Speaking of which, make sure the stopcock is in fact closed, right? You'll only make that mistake 5 times. But this is not the time to make that mistake because chlorine is not very friendly. and 400 milliliters of 31% HCl. Now these are approximate values that correspond to 125% of the chlorine that's necessary. And the reason I'm using chlorine in excess is because this flask will have molten sulfur and all sorts of gunk in it. We want to make sure that all the sulfur is converted. We don't really care about how much chlorine we use. These other reagents are cheap. We want to use all the sulfur because any excess sulfur is going to be very difficult to clean out of the flask. Stopcock is closed. You can see it fuming in the air because the air in here is quite humid. Middle of summer in a Michigan basement. Alright, now that I've got all my acidic glassware cleaned up so that there aren't any accidents, I'm going to turn on the heating mantle and I'll just wait until this reaches approximately 200 to 250 C. The sulfur will be molten and then I can start the flow of chlorine. Slowly but surely melting. Alright, the sulfur looks to be pretty much molten now, so I'm going to lower the tube till it just barely touches the sulfur, and then we'll start introducing chlorine. So of course to start the chlorine generator, just have to turn this stopcock right here, very slowly. Oh yes, and one other thing. I need to turn on the water to this condenser over here. See the green hue of chlorine there. Now that the chlorine flow has started, I'm going to push this tube a little farther in. See, we're bubbling it into the sulfur now. Initially we're going to form a bunch of sulfur dioxide as the water hydrolyzes the formed sulfur chlorides, but eventually sulfur chlorides will begin to form and then distill over. You kind of see there's a little droplet right there of yellow of sulfur monochloride. We're now rounding about our 5th minute, and you can see that the chlorine is bubbling away nicely at a nice and slow drip rate. We'll just continue this until all of the acid's gone. And you can see that there is refluxing here and soaking the joint a yellow distillate, and that would be sulfur monochloride primarily. And the lack of red tinge means that's good because if there was excess chlorine leaving here, this would be all tinted red from the sulfur dichloride forming sulfur monochloride. Here we are about a half an hour in, and I've added this foil to increase the collection rate of the sulfur chlorides. I noticed them refluxing a lot in the flask and head, which kind of makes sense. They're high boiling compounds. So I take a peek in there. That's just the sulfur, the chlorine bubbling into it. The chlorine generator, which is not even half depleted. And you can see I've got a steady collection of sulfur chlorides. It's just started about a minute ago. Something I've also noticed is that the drip rate of hydrochloric acid in is about equal to the drip rate of the sulfur chlorides out. And then the sulfur pot looks like kind of black and foamy. I don't know if I'm overheating it or what. I think the foam might be the chlorides boiling out of the pot, or it could just be that the sulfur is getting really hot and starting to boil. There's some fogginess on the input pipe there, and I'm not really sure if that's just subliming sulfur or boiling sulfur or what. I'd really love to measure the temperature in there, but my air thermometer I seem to have misplaced. So we'll just continue to run like this because it looks like we're getting pretty good yield. And at this rate we should be done in maybe an hour, hour and a half. Something that's interesting to note is that we are using 125% of chlorine that's necessary. And a lot of that is because, well, some will escape the flask, of course, but we have a second chance of recapturing it, actually, because the chlorine, of course, is very soluble in the sulfur monochloride that's formed, which forms this orangey-red sulfur dichloride. And you can see that we have a significant amount of sulfur dichloride in our sulfur monochloride. And in a later step, we'll be distilling this over sulfur to make sure we have sulfur monochloride, and in that step, we'll basically be regaining that yield that we lost by having 125% chlorine. Another thing to keep in mind is that as you lose pressure, as you lose hydrostatic pressure, the drip rate slows down, so this has to periodically be adjusted, even with a pressure equalizing funnel, of course, because the liquid has mass. I've added most of the acid, and we have maybe 25% left, or slightly less than that. So the generator's doing just fine, and you can tell that we're almost done, because if you look in here, you can see that the flask is almost dry. There's just a little bit of sludge on the bottom there, and the residual temperature is just going to take the rest of those sulfur chlorides out. All that's left is just a tiny bit of soot. We just need to run some chlorine through it. I'll run the rest of this, and I'm pretty sure we'll hit this just about perfect. You see, we're still collecting at an appreciable rate, meaning the chlorine is being absorbed, and like I mentioned earlier, there's really no detriment to using extra chlorine. It's been about 3.5 hours, and we have about 15 minutes to go if I judge this correctly. The last of the distillate to come over will take on a deep red color because of the dissolution of excess chlorine, forming mainly sulfur dichloride. And you can see the top layer here on this flask is very dark red, and that's just because there's excess chlorine in the flask, as you can see now by the green tinge above. That wasn't there before, and that chlorine is being absorbed into the sulfur chlorides and causing this dark layer to form here, which means that the reaction has substantially gone to completion, which is good because the acid is just about depleted. In fact, I'm not even going to let the rest of that drain in. Oops, we'll just close it. And see the remnants of the chlorine generator. That'll take a minute or two to settle down. Our production rate has essentially stopped. I can now turn the mantle controller off, as well as the mantle, and we'll remove this foil and see what remains of the sulfur. And you can see pretty much nothing remains. It's just an empty flask that has perhaps a little soot in it, which were impurities in the sulfur. And you can see by the green tinge that it is full of hot chlorine right now. So I'm just going to let this cool down. I'll let the chlorine generator settle down a little bit, and then I can disassemble some of this apparatus, and we can look at our yield. So here's our intermediate product. It's a mobile volatile liquid that fumes in air because it's hydrolyzing to sulfur dioxide, hydrogen chloride, and elemental sulfur as a fine powder. You can see that there's a darker layer on top because it hasn't finished quite absorbing all the chlorine that's on the that's in the flask right now, but those will homogenize in a minute. And then the next step, of course, is just to add some excess sulfur and redistill to obtain relatively pure sulfur monochloride. Alright, it's day 2, and you can see that in the bottom here of this flask that originally contained the sulfur, you'll see where the level was in there by that line. It's just nothing but some soot. No traces of the sulfur left, and that should be pretty easy to clean with some sand and some shaking. And this is the flask with the sulfur chlorides in it. It would be a yellow color if it was just sulfur monochloride, but this has sulfur mono and dichloride in it because there's excess chlorine, which we will aim to remove now. And the way we'll do that is we'll add some sulfur to this and then reflux it for a little while. And then we'll distill off the sulfur monochloride. And the reason we have to reflux first rather than just distill is because the sulfur dichloride actually has a lower boiling point. So we're just going to reflux this until its color changes to a nice light yellow, and then we can go ahead and distill. So I'll swap these out, and I'll set up for that now. The first step, of course, is to add the sulfur to this, and I have here 10 grams of the sulfur I recrystallized in a previous video. We want the sulfur as pure as possible in this step, and you can see that the crude sulfur from the last step left a considerable amount of carbon in the flask because of impurities, and at this step we don't want to introduce any impurities. Although we're still distilling it, it'd be best not to leave those in the flask. This stuff isn't particularly hard to work with, but man, it does stink. This is a good time to use the condenser that was used in the previous step. So you can see it's full of sulfur, and this will actually help remove some of that sulfur. Just, of course, make sure it's completely dry, otherwise you're going to produce a lot of sulfur dioxide. Okay, we're set for reflux. Let's get the water on. And I'll turn on the heating. And we'll let this reflux until hopefully this goes from a dark red to a nice straw color. Alright, I've been refluxing for about 10 minutes, and you can see the color is still rather red, so I think some more sulfur is probably needed. I'm going to go ahead and add 5 more grams of the recrystallized sulfur through the top of the condenser, and we'll give it another 10 minutes and see if it lightens up. However smelly, you can see this stuff is a great solvent for sulfur. That 5 grams I just added, not even a minute ago, has already dissolved completely. You can tell when enough sulfur has been added when the older red-orange distillate starts to get taken over by this lighter colored distillate here of the sulfur monochloride. The sulfur dichloride is the red stuff, which comes over at a lower temperature. You can see that with the addition of the sulfur, despite the bath looking only a little less red, that the distillate is almost purely this yellow color, indicating that we have in fact added enough sulfur, and it's okay to go ahead and cool this down now and set up for simple distillation to recover the product. So I've set up here for simple distillation. I've got a tared flask, 111.195 grams. Standard distillation rig, really. A still head that's easier to clean the sulfur out of. And then the plan is to transfer this stopper to the top of the still head, and then the flask to here. That way I don't have a stinky stopper laying around. And then I'll use the lab jack to bring the heat source up to the flask, and I'll go ahead and distill off the sulfur dichloride. Go, now for some heat. Nice light yellow droplets climbing. That's exactly what we want to see. I'm going to put some foil on this to speed it along. First drops of distillate collecting. And there it is. Okay, well, the drip rate has considerably slowed. That's product. And you can see in there is just a sort of a goopy mess. I don't really think we're going to get much out of that, and it's probably no use heating that further because we're just going to make the flask, number one, harder to clean, and number two, we might start distilling over some higher boiling impurities. And you can see the rate on the condenser there is almost dropped to 0 anyway, so turn off the mantle. I'll just lower it. Pull these off. You can see that there's some decomposition happening by the reddish drops there, so that's why I decided to stop collection. None of them actually made it into the condenser, but you can see we're starting to decompose or affect the equilibrium of sulfur monochloride. So that's a good place to stop. We can now remove the product and weigh it, see how much we have. So it looks like the flask with the stand was tared out. The flask weighed 111.1, the stopper was 18.5. Subtracting from 323.6 gives us 194 grams of pure sulfur monochloride, a volatile orange fuming liquid that smells absolutely horrific. Well, that brings me to the end of the video. I hope you enjoyed watching it. I really enjoyed making it, and if you like this and want to see more, please don't forget to subscribe, like, and comment. Before I go, I'd like to give some tips on glassware cleanup. This is a very messy procedure. Not only is this stuff really nasty and it smells absolutely foul, but it leaves sulfur, solid sulfur, deposited all over the inside of glassware, and it can be a pain to clean up. It's pretty tricky, actually. So the easiest way I found was to first get a bottle, spray bottle here, and fill it with a solution of sodium bicarbonate in water, as saturated as you can get it. Sodium carbonate will also work, or really any base. I wouldn't recommend sodium hydroxide, but you get the idea. Anyway, once this cools down, you open it all up and spray the solution all inside it, and that hydrolyzes any of the sulfur monochloride and sulfur dichloride into, first sulfur dioxide and hydrogen chloride, which then react with the bicarbonate to form carbon dioxide, salt, as in sodium chloride, and sodium sulfite, which then basically takes care of any smells and makes everything pretty much soluble except the sulfur. And then to take care of the sulfur, you just basically reassemble the apparatus and put some xylenes in here. And I did a video earlier on recrystallizing sulfur using xylenes. Just basically distill xylenes through this, and you'll remove 99.9% of all the sulfur that was in it. It'll just end up in the flasks. You can dump the xylenes out before the sulfur crystallizes, and you're good. Of course, watch the flammability and everything. And then the only sulfur that'll be left is just a minute amount in the joints. And that can be taken care of pretty easily mechanically, since those are all fairly accessible with, say, a bottle brush or something.